A really important part of solving equations with rational exponents is relating rational exponents to um, radical expressions. And we've been doing so much work with radical expressions that that's where we start this lesson. There is a paper that you guys do as a group, as a table group in class, and that's this one. It says birds of a feather. This is to be done on the calculator and discussed with peers. And it starts with the radical, square root 16. You can put that in the calculator and you get 4. And what's new is that 16 to the 1/2 power is also 4. 16 to the 1/2 squared. So this is 16 to the 1/2 times 2/1. That's the way the exponent property works, is that if you raise something with an exponent to a second power, you multiply those exponents together. This is 16. Also, we've already gone over square roots. If you square a square root expression, then those are inverse operations and you get 16. Another way, though, this works with exponents is if you had something squared and then you do 1/2 power, then those are inverse as well. So you get 16. So therefore, the relationship between square root x and x to the 1/2 is that these are equivalent expressions. They do the same thing. So I do have this posted so that you can, I have copies if you want to come get a copy, but this goes through the relationships between radical expressions and expressions that have a rational exponent. Rational numbers are any numbers that can be written as fractions. So we're calling this, with math vocabulary, a fraction exponent. Fractional exponent is a rational exponent. We go through these and find that relationship, and then we do these notes, where the big idea is, that rational exponents can be written as a radical expression. And again, rational is the class of numbers that can be written as a fraction. And it works like this. X to the a over b power, the numerator goes as an exponent inside the radical, and the denominator, that's your index. So here, where does the index of the radical go? The index becomes the denominator of the fraction. And where does the numerator for the exponent go? Well, it stays an exponent, but it's inside the radical. To solve equations that have rational exponents, you can rewrite the rational exponent as a radical expression. Then you have to isolate the radical. just like the other radical equations that we solved. So you get the radical by itself. Then you use the inverse operation to get rid of the radical. Really what that comes down to is that you use the index as a power. So here, let's make an example. If you have fourth root of 5x, and this is to the third power, the first step for solving that would be to strip it away in layers. We work from the outside in. So we would raise this to the fourth power to take the radical off, because fourth root and fourth power, so I use this index as an exponent to strip that radical off. That would leave me with 5x to the third, but with no radical then. The next step would be to take this exponent off, and to get rid of the exponent, I'll use the inverse operation. In this case, that means I will use a root. Root is opposite of exponent. So continuing with the same example that I just started, if I have 5x to the third power, to take the exponent off, I do cube root. Cube root and third power are inverse of each other. So I can take the exponent off now, and I have 5x. And then this is, part of an equation. So then you just keep solving for the variable. And lastly, we're working equations, so you can always, check your work. If you substitute your solution for the variable in the original equation, then you can check and make sure that your equation is true, that your solution is correct. Here I have some examples. Where's the top? Here. 4n to the 2/3 power. First, I would write this as a radical. So, and I start with parentheses, so I'm keeping the parentheses. I write this as a radical with 4n inside. This exponent stays an exponent, but now it's inside the radical. And the denominator here, the numerator. The numerator is an exponent. The denominator is a root. It's index. This is equal to 4. These two equations are equivalent to each other. We'll use the steps that we just wrote to solve. We need to systematically undo everything and break this n out of the groups. So first, we will raise to the third power, the power of the index. And if I do that on the left side of the equation, I also do that on the right side of the equation. I can take the radical off now, and I have 4n squared. This will be equal to 4 to the third. I'm just going to put this in the calculator last, just once. Sometimes the numbers get really big, and I don't want you to make a mistake rewriting. So we'll just leave it like this. Now I undo squared. I do inverse of raised to the power of 2, and that is square root, because my index is 2. So I do square root on the right side as well. This eliminates the exponent. So now I have 4n equals square root 4 to the third. I divide by 4 to solve for the variable. and n is equal to this, all this going on. You can put this in the calculator, all in one chunk. Also, this expression is the same as square root 4 to the third power divided by 4. Square root 4 is 2, so I got 2 to the third power divided by 4. So this is 8 divided by 4. 8 divided by 4 is 2. Or you can put in the calculator. Last step of solving equations is to check your work. To check, we'll put 2 where n is in the original equation. So I have 4 times, we found that n is 2. This is raised to the 2/3 power, and I just need to make sure that this is equal to 4. This is 8 to the 2/3. You can put this in your calculator. It's just a quick check, and it is equal to 4. Let's work another one. I need to rewrite this as a radical equation. Be careful when you rewrite. This equation does not have parentheses. This first one did. In this first problem, the part of the equation that has a exponent is the whole left side. It was 4n. That's why I put 4n inside the radical, or 4n squared, cube root. So when I write this as a radical expression, the 2 will not go inside with the x because I don't have parentheses. So I'll write 2 times x is inside the radical. My index is 2, so it's a square root, and I have third power plus 10 equals 138. I need to isolate the radical. So first I subtract 10. So I have 2 square root x to the third equals, let's move that over a little bit. Oh, it doesn't matter, sorry. 128. And I'm still isolating. I divide by 2 because those are multiplied together, and I get square root x to the third equals 64. Now I need to take the radical off, take the exponent off. First step, raised to the second power because my index for a square root is 2. Now I can take the radical off. I get x to the third equals 64 squared. To take the exponent off, I do cube root x to the third. I also need to do cube root 64 squared. So x is cube root of 64 squared. Put that in the calculator. You can also work it out by hand. Either way, x is equal to 81. And to check, it would substitute, into the original equation, just to make sure that 2 times 81 to the 3/2 power plus 10 is equal to 138. And so you check this and it works out. Okay. Next. There is another way to solve these equations. You can write them as radicals. I just did 2 examples where you do that. Another way to write them is, or solve them, sorry, is if you let it be an exponent. Now that we understand the relationship between this exponent that is 1/2, this means square root 2x minus 4 minus 3 equals 3. This is equivalent. What if I solved it, though, as a problem with an exponent? I would isolate the part that has the exponent. So I add 3. And now I have 2x minus 4 to the 1/2 power equals 6. And I need to take the exponent off. Well, this is a fraction thing. If I have 1/2 and I need it to be equal to 1, then I would multiply times 2 over 1. Oops. The reason I do that is because when you multiply fractions, you multiply the numerators together and you multiply the denominators together. Oops. Wow. What's that day? So you get 2 over 2, which is 1. And then you don't have a fraction anymore. If I do that with an exponent, I won't have an exponent anymore. So here I have 2x minus 4, this whole group to the 1/2 power. If I raise this to the 2 over 1 power, if I square it, then you're allowed to do that as long as you also square the other side of the equation. This eliminates the exponent. So then I can finish, solving my equation. I'll have 2x minus 4 equals 6 squared is 36. And I finished solving for the variable. Well, I'm gonna take this party up here. 2x minus 4 equals 36. So I add 4. I get 2x equals 40. So I divide by 2. And I get x equals 20. And then you can check yourself. Just make sure that stop doing that. Oh my gosh. Okay. Sorry. Just highlighted everything. You guys, struggle is real. Okay. There. To check this, we just want to make sure that 2 times 20, that's our x that we found, minus 4 to the 1/2 minus 3 is equal to 3. You put all this in the calculator, hit enter, and it checks out. Okay, let's write steps for what we just did. And then you can choose which way you want to solve them. You can solve them as a radical expression. Oh, I moved my whole world here. Sorry, everything's off now. But you can solve it as a radical using the steps that we did with the examples that we did, or you can leave it as an exponent and solve it like this. Here would be your steps if you choose to solve a rational exponent equation. First, we'll write that on here. To solve as rational exponent. Just as far as we just won't rewrite it as a radical. First, isolate the part that has the exponent. And then what did we do next? We did reciprocal exponent. Reciprocal is a mathy word. It means you flip your fraction upside down. And then we solve for the variable. And you check your work. So here I have another problem that I kind of closed it in. Let's just do these steps that I just wrote, which is how I solved the last problem. X to the 3/2 power equals 729. To solve this problem, this is already isolated. So I do the flipped fraction exponent, the reciprocal. If I do this on the left side, I have to do this on the right side. And so I have just canceled my exponent. It is now x to the first power, which is just x. And that will be equal to 729 to the 2/3 power. That's 81. And you can check it. You would put 81 here where the x is. Do 81 to the 3/2 power and see if that's 729. That's your check. So these last two examples and on your practice problems that you have to work, you can do them as a radical, you can do them as an exponent. I'll do one as a radical and one as an exponent. You can choose how you like to do them. Okay. This one I'm going to rewrite as a radical. 6 plus, this is my denominator, that is my index. So I have x minus 4 goes in here, and this is equal to 9. I isolate this. So I move the 6. I subtract 6 because these are added together. And I have cube root x minus 4 equals 3. Now I need to take the radical off. So I raise this to the 3rd power, the power of the index. So I do the 3 to the 3rd power. Now I can take the radical off and I get x minus 4 equals 3 to the 3rd is 27. You can leave it as 3 to the 3rd. It doesn't matter. I'm going to write 27. And then you solve for x. So you add 4. And we get x equals 31. And you check your answer. You put a 31 where the x is. So I check to make sure that 6 plus 31, my solution, minus 4, raised to the 1/3 power is equal to 9. This last example, I will work, I'll leave it as an exponent. Okay, I'm isolating the part of the equation that has the exponent, and that's this group that has parentheses around it. This is multiplied times -5. So first step, I divide by -5. Now I have a plus 3 to the 5/4 power equals -160 over -5. This is 32. I raise this to the reciprocal power. So 4/5 is my exponent. So I do 4/5 power on both sides. I have just eliminated my exponent. I now have a plus 3. This is equal to 32 to the 4/5. You can put that in the calculator. 2 plus 16. And then you solve for the variable. And you find that A is 13. And you check it. Okay, you put 13 here in the original equation. Just to make sure that -5 times 13 minus 4, plus 3, sorry. Look at that other problem. The 5/4 power is equal to -160.